Alright everyone, last problem for for this new section, and it has to do with secant and cosecant. Now we're just going to do a secant one. Cosecant will be done exactly the same way, just with a different part. Okay, so what we're going to do in this last part is learn how to graph functions in this form or in this form. Okay, so what we want to do is we want to graph y equals 5 secant of 1/2 x plus pi. And let's do it from -7 pi all the way to 3 pi. -7 pi to 3 pi. Alright, so if the problem just asked for the phase shift and period, well, the phase shift is the same as it always has been. It's negative c over b. So that's negative pi divided by 1/2, which is negative 2 pi. The period is 2 pi over b, which in this case is going to be 2 pi divided by 1/2, which is 4 pi. Now, when we get ready to graph this, though, we're not actually going to graph the secant, okay? If you read in your book is going to show you how to graph the secant, but I'm going to show you a different way to go about it. All right, so what we're actually going to do is, instead of y equals 5 secant of 1/2 x plus pi, what I want you to graph is y equals cosine of 1/2 x plus pi. Okay, so cosine is from 0 to 2 pi, so take your bx plus c, set it equal to 0, and set it equal to 2 pi. Okay, when you solve each of these, you should get x equals negative 2 pi and x equals 2 pi. Now this would be our 4 pi period that we got earlier. Okay, and so it will this will be one cycle of cosine. Okay, so here we go. So we have negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, negative 6 pi, negative 7 pi. Remember, we're graphing this from negative 7 pi to 3 pi. So it's going to look something like this. There's 1, there's negative 1. Alright, so we're graphing the cosine function. So let's go ahead, make our t-chart. And so we're starting with negative 2 pi. Well, what is our increment? Well, it's the period divided by 4. So the period here is 4 pi divided by 4. So we're going to have an increment of pi. Going to have an increment of pi. So go ahead and do your increment. Okay, so take negative 2 pi, plug it in for x. So 1/2 times negative 2 this is going to give us a negative pi, plus pi is 0. So the cosine of 0, if you know your unit circle, cosine of 0 is going to be 1. Take negative pi. That's going to give us a negative pi over 2, plus pi, which gives you pi over 2. So what's the cosine of pi over 2? 0. We're just plugging them in. Take 0. 1/2 times 0 is 0. 0 plus pi is pi. The cosine of pi is -1. Take pi, plug it in. That's pi over 2 plus pi, so that's 3 pi over 2. So the cosine of 3 pi over 2 is 0. And 2 pi, so half of 2 pi is 1 pi. 1 pi plus 1 pi is 2 pi. Cosine of 2 pi is going to give you 1. Okay? So this would be for 1 period. Alright, so let's go ahead and graph that. So we have negative 2 pi 1. We have negative pi 0. 0, negative 1. Pi 0. 2 pi 1. So what we have is a graph that looks like this. Okay? Now we need to extend it to cover what we have to cover. We have to cover from negative 7 pi all the way to 3 pi. So if it's 1 here, that means it has to go back down at 2 pi. That means it's got to go back down to the 0 or to the x-axis here. If we follow our pattern, 1 goes to 0. Now we're going in reverse order, so we're at 1 here. So if we're going in reverse order, if we're going this way, then we've got to go back down to 0. We got to go down to -1, back up to 0, up to +1, back down to 0. So that's just following our pattern. And there's our graph of our equation. Now that's the cosine version. That's the cosine version. Now to get secant, what we're going to have to do is we're going to have to take our cosine version here. And what you've got to think about is that secant, y equals secant x, is the same thing as 1 over cosine. But what we're going to want to do first is notice this 5 out in front. We have to multiply all of our y coordinates by a factor of 5 when we get ready to do secant. So there's 5. Okay? So what we're going to do here is now, here's what we have to think of. All these x-intercepts, any x-intercept, okay, any x-intercept is the point x, whatever x is, and 0 is the y coordinate. So if you're thinking in terms of secant, okay, secant is the opposite, is the inverse of cosine. So if cosine has this point, secant if y equals 0 here for cosine, when you do the reciprocal of 0, what do you get? Because the reciprocal would be our secant. Well, what you end up with is you end up with an undefined number, and thus giving us a vertical asymptote there. So at every x-intercept, we're going to have a vertical asymptote. Because cosine equals 0 there, that means secant, because it's the inverse of cosine, is going to be undefined at those x-intercepts. Does that make sense? Hopefully so. So every x-intercept is going to be undefined when we get ready to change it to a secant. Okay? That's step 1 of getting your secant graph drawn. Step 2. Well, first of all, every point here that is a maximum or a minimum. So each of these arcs here are going to be maximums. These two arcs are going to be minimums. well, they're going to be moved up 5 units. So I've got to take this one that's at 1, and I've got to take this one that is at 1, and I've got to move it up. I've got to take this one that's at 1 and move it up a factor of 5. So 1 times 5 gives me 5. So I've got to take this one here and move it up to the 5. Because think of it, it's not moving it up 5 units, it's moving it up a factor of 5. So it's multiplying 1 times 5 to get 5. Same thing here. Move this one up to 5. Move this one up to 5. Now what about the ones down here? Well, the ones down here are actually going to be multiplied by a factor of 5 as well. So instead of going to positive 5, they're going to go to negative 5. So this one right here is going to go down to negative 5. This one right here is going to go down to negative 5. Now, here's the key part about secant and cosecant. Our maxes become mins and our mins become maxes. Why is that? Because when our mins become maxes, that's because we're doing the inverse. Okay? So our maxes are actually becoming much smaller. They're becoming the minimum value. And what was our smaller values are now becoming our maximum values. And also, as we get closer to these dotted lines, you're getting closer and closer to where cosine was 0. Well, this right here in algebra is called the inverse function. So as we get closer and closer to that line, to those dotted lines, by ways of the inverse function, our secant function will go toward positive, will shoot toward positive infinity or negative infinity. So this was a max here. Now it's a min, and it shoots toward positive infinity. Same thing on this side. This was a max. Now it's a min. Shoots toward positive infinity. Same thing here. Now as cosine x approaches 0, our secant x will go toward positive infinity. It'll get bigger and bigger and bigger, okay? Because you're dividing by a smaller and smaller and smaller number. But it will not actually get to where cosine is 0, because 0 would make this function undefined. That's back in algebras where we learned that. It would make the function undefined. So these down here that were mins, now they're maxes. And instead of going toward positive infinity, we go toward negative infinity. Same thing here. Now, these particular, like I said, think in terms of cosine. As cosine gets closer to 0 from both sides, as cosine is getting closer to 0 from both directions, as it's getting closer to 0 from the positive direction, it's getting smaller and smaller and smaller and smaller. But since we're dividing cosine here, we're dividing it 1 divided by cosine. That means it essentially makes it exponentially bigger, which is why it shoots to positive infinity. As we go toward cosine, where cosine is 0 from the right-hand side, we're going from a negative position, so it gets bigger negatively, which is why we shoot toward negative infinity. Hopefully that makes sense to you. If not, there's a good example of that in your book, and feel free to ask me questions. But that would be the graph for y equals 5 secant 1/2 x plus pi. Now the blue is the graph of the 5 secant 1/2 x plus pi. But I want you to also draw the cosine graph on test, okay? Make sure you can do that. It's not required for your homework, but it is required for your test, okay? I want to see both graphs, so keep that in mind. Now, what if we had, what would be the difference? What would be the difference? Instead of secant, what if this were cosecant? What would be the only difference in this graph if it were secant and cosecant? Well, cosecant, instead of graphing the cosine function, you would be graphing the sine function. So this green function here that's graphed would be the sine function instead of the cosine function. That's the only difference in the way you're working these two problems. They're still going to be worked very, very similarly since you're graphing. Now, if you look this up in your book, they're not going to show you like I did here. They're not going to show you to graph cosine first. They're not going to show you to graph sine first like I've told you about here. They're going to make you find the intercepts first and the asymptotes first and go that way. So I think it's a little more confusing the way your book does it. I actually like graphing the cosine and the sine first. I think it makes it easy to see the asymptotes, and then I think it makes it easy to take the maximums and minimums and make the maxes mins and the mins maxes and so on. I just think it makes it easier to graph it like that. I hope it does for you. If you have questions, please do not hesitate to ask. Y'all have a good day.